So hello, my name is Manuel Bajolo, and today I'm gonna be working on my lab number 5. So I'm gonna start by showing my circuit. Here we can see how I have my 10K resistor, which then is gonna be replaced by a 100K resistor connected to a capacitor, which is connected directly to the ground. So on the first leg here on the right of the capacity of the resistor, I have it connected to my digital pin, which is gonna be turned on and off. And I have an analog reading here to read the input voltage. And then I have another analog connected across the resistor and capacitor in order to read the voltage. So here we have the RC circuit simulator response from MATLAB. This blue line here represents the voltage across the 10K resistor, and it reached the maximum, this maximum in about less than 1 second. And the red line here is going to represent the voltage across the 100K resistor, which reached 5 voltage in about 5 seconds, a little bit less. So now I'm gonna move on to my Arduino code. In the beginning, I set up my pin number 2 as an output, my A0 and A1 analog as input, where I'm gonna read the different voltage. And yes, in the beginning as well, I set up pin number 2 as low. I delay for 5 seconds, and then I start. So then I define my value R, C, here, as you can see, and my tau constant, yes. And then I convert my tau to microseconds because my delay is gonna be microseconds. So then in order to delay for an amount of time equal to 10 tau, and at the same time have a voltage reading of tau divided by 50. So I wrote this loop where I first set up the pin 2 as high. I go through this loop, and then once I delay an amount of time equal to 10 tau, I set up the pin 2 as low, and I do the same process. In the middle here, note that I'm printing out the values for my V in and the voltage across the capacitor. So here I run in my code. So this is the processing code. Here I put the text on the beginning of the display of the graph. Here I do it after we go through the first loop. And yes, also a quick note, I changed the size here of the windows. Then I have to modify this loop, the limit of this loop to be 100,000, 2,000. So on here I'm graphing. This graph matches with the graph on the MATLAB. And here I have my reference of my B in, my BC, and my voltage. So now I'm gonna do the same graphing on the processing. Just a very quick note. First, I change here the value for R to 100K. So after changing the value on the MATLAB, on Arduino, sorry, and also on my board, you can be clearly note that the resistor, the capacitor is taking more time to get fully charged and discharged as well. Yep, here it is. So here we are back to the MATLAB, but this time with a different code. So first I'm gonna start by displaying the data collected from the Arduino for the 10K resistor. Here the name of the document was excel.csv. Here we can see that the graph matches pretty well with the theoretical one that we display in the beginning of the video. Another comment I would like to make is I have to adjust here the amplitude for the graph, so I have it on voltage versus time. And finally, as you can see here, I changed the value for my resistor and also the document that I'm reading where I put the data from my Arduino, and here we can see the new graph. Thank you for watching.